Going over 214, so it says compute the average rate of change over the function over the specific interval. So average rate of change is f of b minus f of a all over b minus a. Well, this is your a, this is your b. Okay, so I already have the bottom, right? That's going to be 3 minus negative 3. Now, f of b means you have to plug that in. So if I plug that in, that's 9. 3, so 3 squared. And then the other one, if I plug in negative 3, that also equals 9. So this would be 9 minus 9 over 3 minus negative 3. So that's going to be 0 over, so it'll be 6, so that's going to be 0. So that's the average rate of change. On this next one here, remember this is your a and b. So your formula is f of b minus f of a all over b minus a. So your b is 2, your a is negative 4. So now I need to find what f of b is. So that's going to be f of 2. So that's 3 times 2 squared plus 2 times 2 minus 7. 2 squared is 4. 4 times 3 is 12. 12 plus 4 is 16. 16 minus 7, that's going to be 9. And then we have f of negative 4. So that's going to be 3 times negative 4 squared plus 2 times negative 4 minus 7. 16 times 3, that's 48. Plus negative 8 minus 7. So that's going to be 40 minus 7, so that's 33. So your f of b, 9 minus 33. So then simplifying that, 9 minus 33, that's negative 22. Sorry, 24. And then that's going to be 6. So negative 24 over 6, that's going to equal negative 4. It says find the line parallel. Okay, so that means whatever your slope is, the parallel line, they equal to your slope. So you don't change the slope. Parallel to the given line and passes through the point. Okay, so if my slope is 1/2, that is also my parallel slope. So then, and I have my point, there's my x1, there's my y1. So y minus y1 equals my slope times x minus x1. There's the equation of the line. Great, we're done. Now perpendicular, that means that your slope is opposite reciprocal. So your perpendicular slope, opposite, you add a negative to it. So since it was positive, now it's negative. Reciprocal means it gets flipped. And then you use the same process as above. You have your x1, you have your y1, and then you need to find the line. The local pet shop charges 12 cents per cricket up to 100 crickets, and 10 cents per cricket thereafter. Write a piecewise defined linear function that calculates the price P in dollars of purchasing C crickets. Okay, so we just kind of for notes, it's saying that up to 100 crickets. So when P is less than or equal to 100, but you can't buy negative crickets. So we'll say that. And then P has to be we can say a whole number, right? Because you can't buy half a cricket. They won't let you do that. So that's the first one, because it says up to 100 crickets. And then it's 10 cents per cricket thereafter. So then after that, when it's greater than 100, we probably don't want to include that equal to. It's still an integer, so we could also, if we want, we could say, P is greater than or equal to 101. It just depends on how we want to phrase it. probably can go either way. It's going to work. But essentially, these are like the two ways that it kind of gets separated. So it's 12 cents per cricket. So 12 cents times the number of crickets C. And that's going to be, I should have used C for all of this, right? But this is where it's going to be where the number of crickets has to be between 0 and 100. Now, the issue is when we get to the next one, because you're only paying 10 cents per cricket after. So, having said that, that's 10 cents per cricket after that, but only if it's going to be, greater than the 100. So, I could say C is, there's no equal to, but, the C is greater than the 100. Or 101. But now the problem here is going to be the way that it's written, because if we look at this, if I think about that number 0.1 times 101, well, that's not what this is asking, right? It's not saying, oh, now for all 101 crickets you're paying that new price. It's only per cricket after that 100. So this would actually be 10 cents minus 100, because it has to be after you've already bought 100 crickets. And then the next thing is, but it's still not, if I think about it, if I plug in 101, 10 cents times 1, it's only 10 cents. Well, no, you've already paid the amount for those other 100 crickets. So 0.2 times 100, right? Move the decimal over, right? So that's $12. So that's going to be plus 12, because I've already paid the $12 for the 100 crickets, and now it's 10 cents per cricket afterwards. So if I plug in that next integer, where C is an, you could say integer if you want, you could say C is a whole number, whatever, referring to those, the whole numbers. You can't have half a cricket. But that's it. All right, next one. It says find all the points on the line y equals 2x plus 1, which are 4 units from the point -1, 3. Okay, so there's some... So, just drawing a quick rough sketch, the idea would be, you have this line here. That's y equals 2x plus 1. And you have this point -1, 3. And it's saying, what are all the points on this line that are 4 units away? And that the key is the 4 units away, because the 4 units away refers to your distance. Your distance equals 4. Now, this is going to seem really weird, because the moment that we start talking about distance, it's like, oh, okay, I need to use the distance formula. Yay! So, x2 minus x1 squared plus y2 minus y1 squared. Right? Distance formula. Boom, we have it. But I only have 1 point. Now, the trick is going to be how we set this up, because this y equals 2x plus 1. Right? If I have a point x, y, well, x is your input, is your independent variable. It's what you pick. Okay, that's not really changing. But it says right here, y equals 2x plus 1. So that means I could substitute my y for 2x plus 1. And now, all of a sudden, I'm removing a lot of these extra variables from the equation, which is going to make this thing look a lot cleaner. So we can start plugging our information in. Our distance is 4. And then I could say, you know, this is x1, x2, y1, you know, y2. And so now I'm going to get, so x2, so negative 1 minus x squared plus, and now I get y2 minus y1, so y2 minus y1, which is 2x plus 1, in parentheses, squared, now we can kind of clean this up a little bit. I can get rid of the square root by squaring both sides. So that's going to get 16 equals negative 1 minus x squared plus, now this one here, I got to distribute that negative. So that becomes 3 minus 2x minus 1. I can combine the 3 and the negative 1 together. So 2 minus 2x squared. Now I need to multiply this all out. So negative 1 minus x times negative 1 minus x. So negative 1 times negative 1 is 1. Negative 1 times negative x is positive x. Positive x. Positive x squared. So that's going to be that. And now I got to do the same thing to the other one. So I get 2 minus 2x times 2 minus 2x. 2x times, or 2 times 2 is 4, minus 4x plus 4x squared. And so now that's going to be 4x squared minus 8x plus 4. Now I can combine these together because this says add, so plus. So this gives me 5x squared minus 6x plus 5, and that's going to equal 16. So we're going to get 0 equals 5x squared minus 6x minus 11. So a times c, negative 55, factors of negative 55, that add to negative 6. So that is going to be negative 11 and positive 5. So breaking this up, so I'm factoring it. Factor by grouping, there's an x in common. There's a 1 in common. So that's going to be x minus 1 and 5x minus 11. So your x values are going to be 1 and 11 over 5, right? Because you have to set each one equal to 0. X equals negative 1. Sorry, x equals positive 1, so x minus 1 equals 0, add 1. And then 5x minus 11 equals 0, add 11, divided by 5. Now, these are your x values. What do I mean by these are my x values? These are your x values for this. So that means now if I just plug in my x values, it's going to give me the y values that are 4 units from the point. So if I plug in 1, you're going to get y equals 2 times 1 plus 1. So you're going to get y equals 3. So that's going to be 1, 3. And then for the next one, you're going to plug in 11 over 5. So y equals 2 times 11 over 5 plus 1. So that's going to be 22 over 5 plus 1. So that's 5 over 5. And so y is going to give you 27 over 5. So your point is then going to be 11 over 5, comma, 27 over 5. So these are the 2 points that are 4 units away from that point. So the next is draw and write all the parent graphs for the corresponding equation. So I want you to draw it in that form. So for example, you have your parabolic, and so the family graph for that is a times x minus h squared plus k. For your cubic, that's going to be a times x minus h cubed plus k. So I just want you to do that for all the parent graphs.